All right, math analysis, here are some test review problems that I thought might be helpful for you. First of all, we have a solve problem, and this is already factored, so do not multiply it out, but do isolate the squared term. We want to isolate the squared term, and in order to do that, we need to get rid of the 2/3. So to get rid of 2/3, let's multiply by the reciprocal, which is 3/2. Times 3/2 on both sides, everything cancels. That gives us 5x minus 4 squared equals 50 times 3/2. 2 goes into 50, 25 times 3 times 25 is 75. So we have quantity 5x minus 4 squared equals 75. Utilize the square root property now. Take the square root of both sides. The square root undoes the square. We get 5x minus 4 equals plus or minus the square root of 75. And of course, 75 is 25 times 3. That means a 5 is coming out and a 3 is staying under. This is a quadratic equation, which is why we need a plus or a minus. So plus 4, 5x equals 4 plus or minus 5 root 3. Divide by 5, and that is our solution set. X equals 4 plus or minus 5 root 3 all over 5. Next, we have a rational expression to simplify. And in order to simplify this rational expression, we need a common denominator. These two denominators don't have anything in common, so all we can do is multiply them together. I remind you once again, if there's a minus, change it to plus and make that a negative. So we can then distribute that negative. So let's get our common denominator, which is 2x minus 3 times x plus 3. So what's missing? We're missing the x plus 3. So x plus 2 times x plus 3. And then we've got the negative 4, so minus 4 times what's missing? We're missing the 2x minus 3 times 2x minus 3. So we're going to use the distributive property. We're going to do the distribution here. We'll also distribute here, and then we will combine like terms and simplify. So x plus 2 times x plus 3 is going to give us, let me get that common denominator down. We need it, x squared plus 3x plus 2x plus 6. Take the negative 4 through, negative 8x plus 12. Combine the like terms. So there's an x squared, there's an x, there's an x, there's an x, and then we have our two constants. So final simplified answer, 2x minus 3 times x plus 3, x squared, 3 plus 2 is 5, 5 minus 8 is negative 3x, and then finally 6 plus 12 is plus 18. Now we can do a quick check here. Are there factors of positive 18 that add up to negative 3? No. If 18 was negative, we could factor it. But since 18 is positive, there are no factors of positive 18 that add up to negative 3. Therefore, this is completely simplified. Now, let's do one last step. And let's write in our restricted values. Restricted values are values for x that would make the denominator equal to 0. So here, x cannot be positive 3/2. That would make the denominator go to 0. And x cannot be negative 3. So those are our restricted values, and this is our simplified expression. We're going to be simplifying again, this time with division. And of course, when we have division by a fraction, it's going to turn into multiplication by the reciprocal. So let's factor first, x squared minus 2x minus 8, factors of negative 8. that add up to -2 are x minus 4 and x plus 2. To the bottom, 9 minus x squared. This is the difference of two squares. The factors are conjugates. So 3 minus x and 3 plus x times, multiply by the reciprocal, x plus 3 over x minus 4. Next, now that we have factored first, now we can go cancel crazy. That, of course, is the FFCC rule. Now we can cancel an x minus 4 with an x minus 4, an x plus 3 with a 3 plus x. Remember, x plus 3 and 3 plus x are exactly the same thing by the commutative property of addition. So if we had an x minus 3, we would cancel it with 3 minus x, and a -1 would pop out. So all that remains for our final simplified result here is x plus 2 over 3 minus x. Let's talk about our restricted values for just a moment. Finding our restricted values, remember, when we're looking for restricted values, consider that this is division, so whatever would make this denominator go to 0, or any part of this second half of the problem. Because of the division, neither one of those can be 0 either. So x cannot be plus or minus 3. And x cannot be 4, and of course this would be -3. So those are our 3 restricted values for this particular rational expression. Moving on, let's simplify using properties of exponents. So we have an exponent outside of both sets of parentheses here. So by order of operations, we're going to deal with those first. So 2/3 m to the -3rd, n to the 4th, to the -1. That -1 exponent is applying itself to each one of those bases. 2/3 to the -1 simply becomes 3/2. All we have to do is flip that fraction. Next, m to the -3rd raised to the -1 is m to the +3rd. N to the 4th raised to the -1 is n to the -4th. So there's the first term in this simplification. Next, again, every single base is going to be raised to that second power. So 12 squared. 12 squared, of course, is 144. M to the -2 squared is m to the -4th. N to the -3rd squared is n to the -6th. Now we followed order of operations. We did the exponent on the outside. Now let's actually use the commutative property, and let's group together commutative property and the associative property. Let's group together what goes together. So 3/2 times 144, m to the 3rd times m to the -4th, and n to the 4th times n to the -6th. 3/2 times 144. 2 goes into 144 72 times, and 3 times 72 is 216. M to the 3rd times m to the -4th is m to the -1. We're multiplying. The bases are the same. Add those exponents. N to the -4th times n to the -6th is n to the -10th. Let's finish off this problem by getting rid of these negative exponents. So 216 over m to the 1st, n to the 10th. Only reciprocate what has a negative exponent. That's why the 216 stays right on the top. Next, arc length, like we talked about in class. Remember that arc length is simply a fraction of the circumference. And the formula for circumference, C equals 2 pi times r. So in our particular circle, we have a radius of 20 inches, and we want to find the length of the major arc ABC. The major arc ABC starts at A and goes all the way around this way in order to include point B. So we're after this major arc. So we need to go about this a little backwards. So first of all, our inscribed angle here, it's inscribed because its vertex is on the circle and it has endpoints also on the circle. The inscribed angle is 1/2 of the measure of the arc that it intercepts. So this 25-degree angle is intercepting minor arc AC. So 25 times 2 is 50. So if this arc is 50, it means our major arc ABC is what's left over after subtracting from 360, which would be 310. So our major arc has a measure of 310 degrees. If we're after a fraction of the circumference, that's going to be 310 degrees out of 360 times 2 pi r. 2 pi times r, of course is 20. So from here we need to start by canceling those zeros. So now we've got 31 over 36 times 2 pi times 20. Let's cancel the 2 and the 36 18 times, and then let's cancel the 20 and the 18 by taking out the 2's. 10 here and 9 here. So what do we have left? What do we have left? And all we got to do is multiply straight across here. 31 times pi times 10. So 31 times pi times 10 is 310 pi over all that remains in the denominator is 9. So there's our arc length. Arc length, of course, is linear. So we're going to take that linear unit right up there from the radius and say that this is 310 pi over 9 inches. 310 pi over 9 inches. That's the exact answer in terms of pi. Last, a little parallel line here. Parallel line problem. Parallel lines L1 and L2 cut by the transversal here, forming a triangle. So let's take a look at what we know must be true based on our knowledge of parallel lines. So with this auxiliary line that I'm drawing in, we can see a little bit more about these two angles. Angle X and this angle that is labeled as 40, they are alternate interior angles, and alternate interior angles formed between parallel lines are congruent. So we know that X is 40, and from there we can find out what Z is, because if X is 40, so 45, 40, and the angle that is labeled Z minus 10, all three of those angles have to have a sum of 180. So 45 plus 40 plus Z minus 10 equals 180. Let's combine like terms and solve for Z. So 45 plus 40 is 85, minus 10 is 75. So Z plus 75 equals 180, minus 75, Z equals 105. Z equals 105. So we've got X, we've got Z. Let's go after Y. What do we know about Y? Well, we know that Y is related to a couple of things. So we could do this a couple of different ways. We could say, all right, if Z is 105, 105 minus 10 would leave 95 up top. So 40 plus 95 plus this angle would have to add up to 180 by the triangle interior angle theorem. So let's set that up. So 40 plus 95 plus some angle right there. We'll just call it angle Q because it's the angle in question, equals 180. So 40 plus 95 is 135 plus Q equals 180. That is going to mean Q is 45. So if this angle is 45, and it is directly related to the angle that's labeled 3y because they are vertical angles, then we can say that 3y is 45 and y is 15. So we could have also seen that we have congruent angles here and there. These are alternate exterior angles. That is the second way that we could have solved for y. So y is 15, x is 40, z is 105.